Alright, so this video is where I'm going to work through the guided practice solutions, also give some extra practice. I understand that some of the things that I work through are going to be pretty direct, and that there are questions that you still don't really get the idea about, so that's what this is for, so that I can kind of review some skills that we might need for the test, which is actually next Friday, and also give you some extra practice on the questions that you're looking at. The first thing I always want to do on this video though is go and review the guided instructions so we can talk about it. They want to know if 3, 6 was a solution of this question. If you remember, what we were supposed to do is take the 3 and 6 and plug them in. So you would have put 6 equals, it wasn't supposed to be equals, it should have been something else, but anyway, you'll get away with it, equals 2/3 times 3 plus 4. If you remember about 2/3 times 3, you multiply the number to the top. So it's 6 equals 6 over 3 plus 4, which means that 6 is equal to 2 plus 4, and because 6 is equal to 6, it was a solution. It should have been true in that situation. In terms of what the graph is for y is less than or equal to 1/2 x plus 1, if you were going to graph that, the first thing you should have done was gone up 1 and put a dot. The second thing, because of this being the slope, was go up 1 over 2 and put a second dot. Because there is a line under this, and I'm going to do this without a ruler, but because this is a line under this, that line should have been solid. And then from what we learned today, or in this lesson, that you're supposed to test 0, 0. And so when you put a 0 in for y, and a 0 in for 1/2 times 0, 1/2 times 0 is of course 0 plus 1, you end up with a true statement because 0 is less than or equal to 1. And so because this is true, you want to stay on that side of your graph and shade the bottom. So hopefully that's where you did your shading, so you can go ahead and get your points for that one. Number 3 talks about a party where you could spend no more than 12 bucks. Peanuts cost 2 per pound, cashews 4 per pound. They just want 3 possible combinations, and for the most part it's just something where you can say peanuts, cashews. Honestly, I would just start with the obvious. If you're talking peanuts at $2 per pound and you can spend no more than 12, I would say 6 pounds of peanuts, 0 pounds of cashews is one thing that works, right? Because 6 pounds of that's going to be 12 plus 0. You can also do 3 pounds of cashews, 0 pounds of peanuts, and then anything beyond that that you find is pretty easy. Also, actually, that helps you to graph it there, because in terms of your graph, which looks like this, that's the peanuts and cashews. The peanuts would be at 6. The cashews would be at 3. The line would go there, and you would actually have that general area there to look at. You would shade anything on this part here because you want to be less than that. But other than that, you could have 1 pound of peanuts, 1 pound of cashews, 1 pound of peanuts, 2 pounds of peanuts, 1 pound of cashews, anything like that. Works on that. So again, as long as you kind of checked that out and made sure it worked. And then number 4, when they wanted the equation, the first thing you recognize is that your y-intercept is -2 and that you have to find a slope. Well, when you looked at this, you sort of saw your second point here, which made a slope of 1/3. So you're looking at y. I don't know what the symbol is yet, but we'll see. And then you have 1/3 x minus 2. Now we know that 0, 0 should be false, so we need to do a little bit of work. So 0, again, I don't know what the symbol is. 1/3 times 0 minus 2, 0, and then we have 0 minus 2, 0 over here, -2 over there, and again, this should be false because we're not shading towards 0, 0. And so if it should be false, then what we are looking at here is the fact that this shouldn't be, if it's going to be false, it's dotted. It should be here with that symbol there going on. Alright. So getting to the practice and instruction again, hopefully you're doing this at home or doing this at some point again to where you can see what's going on. This is a review here. Actually, it's back on this side. Going back to the original page, is what's the solution of the following system? I don't know if you remember this from last week or from the week before school was out. Remember that if you have 2 lines and you're talking about a solution, the solution is where the 2 lines cross, and it's the ordered pair where the 2 lines cross. So if you were doing that, the solution of this would be -1, 1. That is your solution. Again, whenever you have 2 lines and they want to know what the solution of the system is, or a solution of graphs, Whenever it's just lines, the solution is where the two lines cross. I need you to remember that and keep that in mind. You also have a problem like 2 that you will be seeing on next week's test, so you might want to make sure you pay attention to that. When we saw this, we had two options of substitution and elimination. And what we learned was that anytime there is a regular variable all by itself, that we want to use substitution. And so we're going to take this part and plug it in there. And so you end up with 4x plus 3 times x minus 19 over 4, which is going to be ugly, equals negative 9. I didn't know it was going to be this ugly. But let's see what happens. We have 4x plus 3x, because that gets multiplied. And then if you remember fraction times a whole number, multiply the 3 times the top number, so 3 times 19, which is 57. So minus 57 over 4 equals negative 9. Let's put our like terms together first. So you end up with 7x minus 57 over 4 equals negative 9. Well, I am purposely giving you realistic numbers because you have to be able to do this. And what we learned, if you remember that week that we took to work on this, is that if you have a fraction and you don't really want to deal with it, just multiply by the only fractional number there, which means I'm going to multiply everything by 4, which turns this into 28x minus 57 equals negative 36. Then I work this out, add 57 to both sides. 28x equals, I think that's 21. Negative 36 plus 57. Let me make sure I don't want to mess up on here. That is 21. And then when you divide by 28, you end up with a fraction that must be reduced, which is 3/4. So that is x. And so in the end, you take this 3/4 and you plug it back in. I think the easiest thing to plug in your x for would be here, and I'm going to show you why in just a second, because anytime you have the y by itself, all you have to do is plug in for the x and do the work. And if you remember, I showed you how to do the fraction part on calculators. Watch carefully. Remember, every time you have a fraction, put that fraction into parentheses. So 3/4 minus parentheses 19/4 equals, of course, we get a nice number like negative 4. That works. So that means that y is negative 4. And so our answer is 3/4 comma negative 4. Make sure you bring some of that back to your memory, and especially some of the things that we did here. Again, this is not stuff that you're going to definitely see this week, but on your test there's definitely going to be some fractional numbers, some ugly numbers on there for you to work with. This question here gives us another problem where we have to use substitution or elimination, and they want the value of x plus y. Again, this is a question you're going to see on your test. It's good for you to see it now. Keep in mind that if you're going to try to find the value of x plus y, the first thing we have to do is find x and y and then add them together. Whereas the question 2 wanted the solution to be solved. This is the solution because it represents the point where the two will meet. This question is simply asking for what the value of the sum is. So we have to solve it and then take and add them up. So in this situation, because y is by itself, even though it's over here, the best thing to do again is substitution. And we're going to substitute for y. And so we do 3x plus 15 times x minus 1 over 15 equals 11. So again, 3x plus 15 times what we put in for y equals 11. Then we put our 3x plus, multiply this, 15x minus, multiply by the top, 15 over 15, which actually ends up being nice, equals 11. 15 divided by 15, of course, is 1. So we'll put this together here. 18x minus 1 equals 11. Adding 1 to both sides to move it, you get 18x equal to 12. And if you don't know what 12 over 18 is reduced, again, I showed it to you here. Do 12 divided by 18 and then do math, enter, enter, and it reduces it to 2/3 for you as your first answer. So we now take this 2/3, which is our first answer, and we plug it in. Again, it's easier to plug into an answer that has y all by itself. So we do 2/3 minus 1/15 equals y, and we will again use our calculator. So I have to use parentheses anytime I use fractions. 2/3 minus 1/15 equals, well, I don't want the decimal, so I do math, enter, enter, which shows me 3/5. And so this is not my answer where I put this in the parentheses, that in the parentheses, because they want the value of x plus y. And so my final answer is going to be whatever 2/3 plus 3/5 is. I know we can do it in a calculator, but let's do this the old-fashioned way where we say 3 and 5 meet at 15. If you remember doing that, because I have to multiply 3 by 5, this turns into a 10. Because I have to multiply 5 by 3, this turns into a 9. And you end up with 19 over 15, because remember, you add the top and leave the bottom alone. Just to verify that, 2/3 plus 3/5 equals math, enter, and there's your 19/15. So that would be your final answer there to that question. Alright. And then some real quick graphs just to make sure that we see some examples on just graphing in general. If you were asked to graph this inequality, the first thing you would do is look at this number here. Again, this is slope-intercept form because y is by itself, and so this is telling me to go down 1. So first thing I do is label that I'm counting by 1. I go down 1 and put a dot. This -4, again, remember that that's -4 over 1, so it means go down 4, 1, 2, 3, 4 over 1, and put my second dot. The other thing that we learned in this lesson is that that line means that I should use a solid line all the way through. And then the last thing that we learned is that because this is an inequality, I have to test 0, 0. And so I test 0, 0 to see if it's true or false by plugging 0 in for y, 0 in for x. Again, anything times 0 is going to be 0 minus 1. 4 times 0 again is 0. Is 0 less than or equal to -1? I don't think so. 0 is actually bigger than -1, which means this is false. And because this is false, it means that that's the wrong side of the line. So we would jump over to this side and shade here. Alright. Again, I hope you're taking notes on this stuff, trying to get ready for it, but it's just something you have to practice. Looking at graph number 5, this is not slope-intercept form, which means that I need an x-intercept and I also need a y-intercept. Whenever y is not by itself, I need both of those. And so what I will do is find the x-intercept by ignoring y and treating this like an equal and put 4x equals 12, which means, of course, that x is equal to 3. So reminding the teacher that I'm counting by 1, I put my 1's down, 1, 2, and 3. There is my x equals 3. I need my y-intercept. In order to get my y-intercept, I ignore x, but I have to remember that this 3 is negative. And again, treat this like an equal sign to find out that y is -4. So 1, 2, 3, 4. There is my -4. The trick here again is there's not a line under it, and so I have to make sure that I use a dotted line. And then in the end, because this is an inequality, I have to test 0, 0. And when I test 0, 0, again, 4 times 0 is going to be 0. Minus 3 times 0 is also going to be 0. And then we work this out. Is 0 smaller than 12? Yes, it is, which means I'm standing on the correct side because it's true. And so I shade everything on this side of the line. Alright. Got a few more graphs I just want to do just to make sure we've got it. Some of the trick graphs again, which is why this is extra practice, so you can kind of look at some questions that aren't in the original notes that make you think a little bit. Here you have y is greater than -x. I see part of me saying that it's in slope-intercept form, but it's just weird because I'm used to having two things. Well, if you think about it, y is greater than -x is almost like having a plus 0, which means that the y-intercept is 0. Again, don't forget to label that you're counting by 1's. -x, of course, means that this -x is the same as having -1x, which means your slope is -1. Slope of -1 means go down 1 over 1. And again, this is a dotted line or dashed line because there's no line under it. And so that is the kind of line that we will draw all the way across the region. Here is the problem. I cannot test 0, 0 because 0, 0 is there. And so what I'm going to do here is I'm going to pick an easy point that is actually on one side, and the coordinates of this are 1 and 1. Notice 1, 1, over 1, up 1. I can test any point I want just to see if it's true or false, and so this is what I'm going to check. So I'm going to put 0 in for, or 1 in for x, 1 in for y. So I put 1 greater than negative, parentheses 1, which means 1 is greater than -1. That is a true statement. And because 1 is bigger than -1 is true, it means that I picked the correct side, and so I stay there. Again, if I would have plugged in 1, 1, and it would have been false, that means that I would have been on the wrong side, and I would have had to jump over the line and shade the other side. Number 7, talking about x is less than or equal to 4. Again, this is my x-axis, my y-axis. I'm counting by ones. X is 4, 1, 2, 3, 4 here. And again, remember, anytime I have one variable, that I usually pick that line that goes through it, and I test 0, 0 because it's available. Once I test 0, 0, put a 0 in here. Is 0 less than or equal to 4? That is actually true, which means that I picked the correct side, and so I will stay on that side, which means that I will go here. Number 8 has a y is equal to equation, and so what I will do is, again, this is my y, this is my x. I'm counting by ones in both situations. Y is -4, 1, 2, 3, 4 here. Because it's a one variable equation, it means go through that axis, and again, that's a dashed line because there's no line underneath it. Because it's already there, I just use that. And we're going to again test 0, 0. Is 0 bigger than -4? Actually, it is bigger than -4, which means that that's true. So we again have picked the correct side, and we will shade above that graph. Again, if your 0, 0 or whatever point you choose is false, that means that you have to go the other way, because if it's false, you're on the wrong side of the line itself. Then let's look at one more graph like this, or one more picture like this, where it talks about a music store using or selling used CDs for $5, and they buy used CDs for $150. You go to the store with $20 and some CDs to sell. You want to have at least 10 left when you leave the store. So here's the thing. This one's actually crazy because it sells used CDs for $5 and it buys used CDs for $1.50. And so what you have to do when you make this is understand that you're talking about you're buying some things. So again, if you're buying the CDs, it's going to cost you 5x. Again, if x is the sold, or sorry, x is what you purchase, and y is what you sell in this case. 5x, because it's going to be $5 per your purchase. But if you get $1.50, it's going to take away from your purchase, or it's going to take away from your total. So really, if 5 is going to add to your price, then your y is going to actually take away from your price. So we would actually subtract 150 from that price. So it would be minus 150y. And again, you want to have at least $10 left. Alright, so it says you go to the store with $20 and some CDs to sell. You want to have at least $10 left when you leave the store. I think what we are looking at here is the fact that if we go with 20 and we want 10 left, then we should that should be no more than 10. Again, here's why it's no more than 10. I went with 20. I want to leave with at least 10. That means I don't want to spend any more than 10 bucks at the store. That's what I get out of that. And so when I go to graph this, again, x would be your purchased CDs, and this would be your CDs that you sell. That's your first label. The second thing is I have to make sure I know what's going on in terms of my graph here. And again, this is not standard form, so I need to make sure that I look for my intercepts. My x-intercept, of course, is ignoring y. I get 5x. Again, turn that into equals of 10. And x is, 2? And I think that I can probably count by, I don't know, let's go ahead and count by 50 cents, 20 cents. 20, 40, 60, 81, yeah. 40, 60, 80. So this is $1. 20, 40, 60, 80. This would be $2. 20, 40, 60, 80. That would be $3 on that grid. So again, counting by 20 cents, that would give me what I need there. If x is equal to 2, that means that that's where that number goes. But here is the hard part. I think that this minus is going to throw everything off because you're talking about your y-intercept representing the 10. And so what we're looking at here is the fact that you're looking at negative 150 y equals 10. So we have to divide 10 by 150, which gives me 6.66, which based off of what I know is 6 2/3 if I turn that into a fraction. Yep, 6 2/3. And so what I could do is 1/3, 2/3, 1, 2/3, 2, 3, 4. Well, it doesn't work that way. I think I'll just go ahead and do the regular way with just the 1. So I'll go, so it's negative 6 2/3. But again, here's the issue. You're talking about going down 6 2/3. 1, 2, 3, 4, 5, 6 and 2/3, and then you're having another dot over here, which means that we have to kind of probably extend this out a little bit or figure out what the slope is. But I think that what we need to do probably is I'll just go ahead and extend it just to get the line itself. Again, just for the sake of the line, I'll extend this down, try to keep this as basic as I can. 1, 2, 3, 4, 5, 6, 7. So 6 2/3 is about there. What I said earlier is still true. You cannot go below that line because you would not have a negative number of sold CDs and a negative number of purchased CDs. So we are looking at just this portion of information. Again, this is part of the line, but because that's in a negative number of sold CDs, you can't sell negative 1 CDs or negative 2 CDs. That doesn't make sense. So the graph itself would be here, and then we have to test 0, 0 because we need to know where our shading is. I'm assuming it's on this side, but let's just see. Is 0 minus 0 less than or equal to 10? And that would be true. So yes, your shading would be here. So the graph that you have here, because remember this line is going to go forever, it's going to be a whole lot of options here based off of what you see. Actually, that's not 2, that's just a number 2. So you could purchase 1 CD, sell none. You could purchase 2 CDs and sell none. You could purchase 2 CDs and sell 1. You could do all kinds of stuff. All these things here are your potentials. And pretty much, again, that's what you're looking at there. Because this was below it, because we can't graph the negatives, that's what puts me where we need to be there. So outside of that, again, look at that information. Practice the information. We're going to get some time to review next week. Just make sure that you're asking about what's going on and trying to figure this stuff out, because again, it is a fight. It's kind of weird because of the graphing part, but just make sure you're working on the skill. There really are no excuses because you have all this time to ask questions in class and look at the videos and learn from the videos. So make sure you're doing what you need to do. But like I said, if you have any questions or need extra assistance, use me, use the people around you, and let's continue to move on.